Hello, my name is Edward Baum, and this is my autonomous drone presentation for my computer science capstone project. What we'll be talking about today is an autonomous drone. We're using Ardupilot software, and within Ardupilot software, we'll be using the software in the loop testing environment, and we'll be connecting that software in the loop environment to a ground control station so that we can see visually how the drone is executing those commands. We'll also have written a Python script of which we'll show in the next demonstration, and we'll be using DroneKit API to send that Python script to the drone. All right, welcome to the next part of the demonstration. Here I'll be presenting the simulated vehicle and the steps taken to launch the software in the loop program. All right, first step is to locate the sim vehicle program within the SIGWIN terminal. SIGWIN terminal is a Linux-based terminal used to launch Linux-based softwares on a Windows operating system. Go to CD Ardupilot. Go to the tools directory, and here finally we'll go to the auto test directory because the SITL program is a testing environment. We'll launch the SITL program here. Sim vehicle package. It's important to verify the correct vehicle. Here we're flying a quadcopter. Now that code will compile. Once compiled, the code will launch a Mavlink terminal, of which we'll use to send commands to the simulated vehicle. While that's compiling, we'll enter the directory where the drone script is located. Alright, here we have our Mavlink terminal. Okay, our next step is to connect to our ground control station. Alright, that's updating all the parameters. Here we are, we're connected to our mission planner ground control station. What this is going to do is that it's going to show us every command that will be executed by the simulated drone. Here on the left panel, we have all of the data that is being simulated through this simulated drone. The cool thing about this ground control station is that when we actually decide to use this program or any of these commands on an actual drone, this is exactly what we will see when our drone is out there in the physical world doing all these commands in real time. We're going to do some preemptive commands here to make sure that everything is okay and that ground control is ready for our drone script. We don't want to launch the drone script and have any errors in the code, and then that drone will be stuck in the air or flying in space. Here we'll change the mode to guided. And now we'll arm the quadcopter. Arm throttle. Alright, see, we're doing very well here. We've armed, and now we'll give the command to take off. I gave the command to take off to 10 meters. The system runs in meters. So it's going up, the altitude is rising, and once it's reached that target altitude, we'll give it the command to land. And now it's going down. And we're almost there. Okay. And we disarmed. Now that we know that our commands are working, ground control is understanding and showing us everything that that drone is doing, we're going to launch our Python script. What this is going to do is that it's going to elevate in altitude, and it's going to move up and down and forward and back, or north and south. Here we have the drone moving north. So every time it gives me one of these messages, it means that it's sending that heartbeat to the drone. Alright, it's taken a while for ground control to realize the drone script. However, here in our Maven terminal, we're seeing that all the commands that the script is going through are being represented here in this Maven terminal. Okay. You see here we have the drone moving. And unfortunately, ground control only showed half of the probe. Once the drone lands, I'll launch the Python script one more time to see if it will launch it the correct way. All right. Let's go one more time. Okay. So my ground control station at this point in time is not really registering the Python script. However, we can see that this home base here is where the drone began. So what the Python script did is that it made the drone fly up in altitude, move forward in the north direction, and then move south, go up and down, and then land. As we'll hopefully soon see after the Python script has terminated. Here we go. Alright, it did the same thing again. But let's look at here in the Maven terminal. We'll see that every now and then we'll get these flight battery percentages. These flight battery percentages are very important because you need to keep track of your battery. So once your battery reaches 0, your drone is dead in the air. It's something that you need to keep track if you're thinking about the physical drone or the true end product. That kind of information is critical. All right. I'll end this part of the demonstration, and the next part I will go through the actual Python script. Welcome to the next part of the demonstration. Here we'll have the code walkthrough. Now the first part of the code is the connection part of the code. Here we have a parser object. Now with this parser object, we're going to create an argument, a connect and a default IP address. What this default IP address is in the event that we don't have an IP address to pass through this argument, we're going to default to a simulated vehicle IP address. This next part captures the value, saves it to a variable called args, which will then be passed to our connection string. And our connection string is used to create that vehicle object. Now here, this part is pretty important because in the event that a connection string is not established, the script will create a simulated instance of the drone to execute that script. Now remember that Ardupilot has its own simulated vehicle program, where DroneKit has their other own simulated vehicle program. In the event that there is no physical drone and that there is no Ardupilot simulated vehicle program, DroneKit will launch its own simulated vehicle program to pass as a vehicle object. This next part of the script will be the arm and takeoff. Once we've connected to that drone, it'll be safe for us to start arming the vehicle and taking off. Now we have our basic pre-arm checks, which is making sure that the vehicle is armable, meaning that we need to change the vehicle mode to guided. The vehicle will not launch when in stabilized mode. Now once that vehicle is in guided, then we're going to arm the vehicle. We're going to give the command of takeoff, and we're going to pass the given altitude, which in this case will be 15 meters. Now once that vehicle is in altitude, we can begin to understand the velocities that are in motion to move that vehicle north, west, south, or east. Now here, I'm going to explain what's going on over here. So we have our drone modeled in an XYZ plane, meaning position, velocity, and acceleration. So what this next script is doing is that it's sending a velocity command, being the heading of the drone. Velocities will be an input of the XYZ, that's that position, velocity, and acceleration. So here we make a manual mavlink message, and we populate the different fields to get that unique behavior from that method. These are the different fields. Depending on what is in our X, Y, and Z, the drone will move in specific directions. So this first function here is what's deciding where the drone will go from the direction of the nose of the drone, whereas this next function under it is deciding where the drone is going to go relative to the global direction of the Earth. So you have your true north and you have the north as it relates to the nose of the drone. Let's go over how the drone moves. So once the drone is in the air, we'll give the command for the drone to move north. And so here you have that XYZ plane, and this will move the drone north. We'll move north, and we'll wait there for 1 second, and then we'll begin to move west, and we'll wait there, and then we'll move north again, and then west again, but as it relates to the global cardinal directions of the Earth. The next part will be us moving up and down, and then we'll hover, and we'll land by switching that mode to land, and we'll close the vehicle object. All right, now that we've seen all the pieces working together, we've seen the Cygwin terminal running a Linux-based program on a Windows operating system. We've seen the command prompt and how we ran that drone script and executed those commands on the ground control station. We've also seen the Mavlink terminal and all the potential and data that is given through the Mavlink terminal and commands that we can give the simulated drone through that terminal. We've also done a code walkthrough to understand how that code is written in the different sections that are included in that code. The connection string, the arm and takeoff, the velocities and XY plane, understand how the drone is moving in those cardinal directions related to the drone and also related to the global signal or global positioning of where that drone is located. We've done it all. We've seen that drone move autonomously. So we can take that same exact procedure, take all those same steps and plant that into a physical drone and that physical drone will move exactly how that ground control station is seen. Now I'm seeing a bright future for autonomous drones. It's so fantastic. It's exciting to see drones and where they used to be and where they're going now. Seeing Amazon Industries might be using them for future package droppings. Seeing how Wuhan, China used drones to spray COVID infected areas during the pandemic, and how drones are being used now in farming to cast out fertilizers and insecticides. I mean, there's no telling the possibilities of where drones are heading. Definitely, military has had the drones for many years doing unmanned missions and all the such like that. It's a really exciting platform to get into, and I'm really excited that I got to do this project this semester. I mean, it was a really fun project to do. Unfortunately, I didn't have enough time to really get down and understand and write the code deeper to develop that delivery program. However, I did understand all the concepts and all the steps taken to make that delivery program. So this is the end of my presentation. I hope you enjoyed it. Again, I'm Edward Baum. Have a great day.